So you've done your experiment. You've randomly assigned some people to have the option of enrolling in Medicaid and some people to be in the control group. And you've waited a year, you've gathered your data, and now it's time to look at the outcomes and see what the results are. So here we've got all our outcome data of our experiment. Over here we've got a whole bunch of different outcome variables that we're interested in. We've got blood pressure, cholesterol, hemoglobin, depression measures, and cardiovascular risk. And if you're a medical doctor, then all of these variables have lots of meaning to you and why they matter for health-related outcomes. So what we want to know is what is the effect of having Medicaid on things like positive depression screen. So this is a measure of whether you're depressed or not. So does having Medicaid lower depression, make you less depressed? Well, we're going to find out very soon. So remember that experiments are relatively easy to analyze. We just want to compute the average treatment effect, which is the difference between the average outcomes in the treatment group and the average outcomes in the control group. So over here in column 1, they've given us the mean or average value in the control group. So for example, all of these are means, and in the control group, 30% of people had a positive depression screen, for example. Now, they haven't given us the average values in the treatment group, which is an imaginary column right here, okay? But what they have given us is the average treatment effect, which is taking the average value in the treatment group minus the average value in the control group, and then that gives us this column here, column 2. Okay, so these numbers here are all differences between the average value in the treatment group and the control group. So for example, for positive depression screen, we have an average value of 30 in the control group, okay, 30. And then the difference is minus 2.21. So the value in the treatment group is about 28. So only about 28% of people in the treatment group are depressed, whereas it's 30% in the control group. So from this number, it looks like being in the treatment group lowered whether you got depressed or not, okay? So because this is an experiment, we know that this number here, this average treatment effect, minus 2.21, is a true causal effect, okay? We don't have to worry about confounders or a selection problem or anything like that because of random assignment. But we only have a finite number of people. We have to deal with the fact that we just gathered some data. We didn't actually do the experiment on everybody in the state of Oregon or everybody in the whole country. So we have to worry about finite sample problems. That means statistical inference, okay, in addition to causal inference. That's exactly what these numbers here in parentheses do. These are our 95% confidence intervals. Okay, so let's talk about how we interpret these. So here we've got the 95% confidence interval for the average treatment effect of having Medicaid on positive depression screen. So here's the interval, minus 4.02 to minus 0.40. The first thing you ask with confidence intervals is 0 in the interval? No. It's not. If 0 is not in the interval, you conclude that your estimate of the average treatment effect, minus 2.21, is a statistically significant effect. That means that it's not due to the particular people who happen to be put into your sample in the experiment. It's really a true causal effect. So just because we found that this confidence interval doesn't have 0, we conclude that it's a statistically significant effect. But that doesn't mean that it's a clinically significant effect. So is a minus 2.2% decrease in depression something that matters as far as the world's concerned? Well, that's something that you'd have to go to a medical doctor to think about. But as far as we're concerned, there's no problem with small sample size. We've been able to detect an effect. Being in the treatment group here lowered depression by 2%. Now, in the next module, we'll look at another one of these variables where this confidence interval actually has 0, and then we have to start thinking about a few different things.